Welcome to module 4. In this module, we will see summarizing the data, the tabular presentation, how the data can be summarized in tabular form. So let us start with the first section of this module, and this section will introduce different kinds of the data summarization methods. So in one sense, the purpose of statistics is extracting the knowledge from the data. So if I present the raw data, if the raw data is extremely exhaustive, for example, if it has got more than 1 million data point, for example, the census of India, so it is extremely difficult to make anything out of it. If you want to actually make some interesting data out of this, the data, so extract the knowledge from the data, then you have to actually summarize it in a set of number or in very interesting figures. So the two ways, either by the table or by the figures, of course. So this module is all about the tabular summarization of the data. So for which we have to organize and visualize the data. So the data visualization is extremely important just after the generation of the data. The data has to be visualized first because we have to extract the knowledge from it. So one prerequisite of the machine learning as well as artificial intelligence is also the data visualization. Is extremely important in the field of AI. For example, have a look at these two graphs. The first graph or the lower panel, the graph says the countries of the world where the tap water is potable. For example, can you drink the tap water in India? It is not, right? But many of the countries, the tap water is potable. For example, Australia or Japan, or most of the countries in the Western Europe or Canada or the US. Another graph here is world map, in which the press freedom index of 2015. It can be 2018 as well, the latest data. So here, this is just a way to represent extremely complicated data in a more accessible format. So that is the purpose of the data visualization. Before that, let us start with some definitions. So what is variable? So variable is the quality that may vary from object to object. So it's a quality or an attribute that can vary from object to object, or the elements in the data set is called the variable. So sample or the data set is collection of the values of one or more variables. So number of sample is known as the element. So a number of the sample, so any kind of the sample, so sample one of the sample or one data point is known as element. So size of a sample is the number of the elements in the sample. So how many elements are there in a sample, that is called the size. For example, to know, to study about the smokers in Indian population, I identified around 500 smokers. So the 500 smoker is my sample. Sample is a subset of the population. Population means all smokers in India is the population. A subset of it is sample. My sample has 500 elements. Each element is each smoker which I identified, or it's also called cohort. So 500 elements we have. So how many elements are there in my data set or the sample? There are 500 elements. So the 500 is the sample size. Size of the sample is the number of elements in the sample. Here is another interesting data about the key punching error or the typing mistake. In this case, the variable is, the errors in each line. So if you type multiple line continuously, each line, how many errors are there? So each digit represent number of errors in each line of typing. So this is also a variable, though it's only one variable that is being measured. That variable is errors per key line, per the line of the data entry. And as you see, this is a discrete variable. It's not a continuous variable because you can actually catch hold of it. And there is no 1.5 errors. So it's only either one error or two errors. So variable is presented in the capital letter. For example, capital X, and its value is actually in the small letter, small x. So for example, X could be the capital X could be the title of the book, and the small x is the biostatistics by Fisher and Belay, could be the value of that particular variable. Qualitative or categorical variables have non-numerical, that is of categorical values. As I told you, for example, rock or taxonomic rank like species, genus, family, order, etc. These are also qualitative variables. Gender of the child, race, cause of death, all these are examples of the qualitative variable. Some qualitative variables can be ordered or ranked. So, while many cannot be ordered, for example, how happy do you feel right now? So, I can still order it from the scale of 0 till 10. You know, with the more happiest person will say 10, while unhappy persons will say 0. So, rank ordering is possible in certain categorical variables. So, quantitative variables have numerical values. For example, number of particles emitted by radon counts per minute. As you see, it is a discrete categorical discrete variable, quantitative variable. Total number of calcium in patients with osteoporosis, number of children or parity, again that is a discrete, the other one is actually a continuous variable, while this is discrete variable. Discrete quantitative variable versus continuous quantitative variable. So, that I have already explained to you, these are all quantitative variable, you can assign number to it. So, data summarization is extremely important because presenting the raw data is not practical in many cases. As I told you, one example is census of India, it is extremely complicated to make anything out of it. So, if I present the raw data, so I have to be effectively summarize this raw data into into a meaningful manner. So, epidemiological study that involved blood glucose measurements from a lakh sample, you see again 1 lakh is a lot of sample size, and a raw data you cannot actually make anything out of it. Human genome, the entire human genome if printer would occupy 130 volumes and takes 95 years to read. So, human genome is extremely complicated, you see it is exhaustive in the data. So, data mining is extremely important. Data mining means that you extract meaningful inferences from a large data set, that is called data mining. Such raw data convey no easily comprehensible information. What are the general trends? Are the distribution roughly normal, or are the data unimodal or multimodal, or are there any obvious clusters? Are there any anomaly? All these questions you cannot make out from the raw data, you have to summarize it. But remember that the raw data is extremely important. You should never oversee this raw data. If you have if you actually made this data by yourself, you actually accumulated the data, experiment, you did an experiment and you have the data with you, the data has to be entered properly in your notebook. You should never erase this raw data. So, raw data should never be dismissed as useless. The data should be carefully archived either in physical form or in online archival tools that generate the digital object identifier such as lab archive. So, you can put all your raw data into the lab archive and that generate one DOI number. So, that number you can quote it in your papers. So, it should be available for an inspection at any time. So, if anybody is having a credible doubts about your data, then they will ask you where your raw data is. So, you can never delete your raw data. So, the term data mining is about extracting the meaningful information from the raw data, that is called data mining. For example, what are the genes in the human genome? As of now, it is around 25,000 genes. We know it, or up to 30,000, some estimates say up to 30,000. So, these are something called data mining. We are actually mining a large raw data set for meaningful information. The way the data is presented is very important, although often overlooked aspect in the statistics. Data summarization comes much before any statistical tests. So, remember, data summarization is not statistical test, it is just summarizing the raw data. So, choosing appropriate statistical test depends on the general trends of the data revealed in the summarization step. So, you have to summarize first, then based upon the summary you make some inferences, then you decide what kind of test should I go for. So, there are two main methods for summarizing the data. The first method involves the tabulations or the frequency table, or its numerically you can actually summarize the table. For example, empirical frequency distribution, or EFD, or empirical relative frequency distribution, or ERFD, or empirical cumulative frequency distribution, that is ECD, or you can also do contingency table, or the table containing descriptive statistics. So, that is called summary table. All these are tabular summarization of the data. The other way is you can use figures, the graphical and figures. So, that is visual summarization or data visualization. For example, stem and leaf diagram, box plot you can do, histogram or ogives you can do, and different kinds of charts you can make use of it, that we will be explaining in our next module. So, choice of table or the graph for the data visualization is largely a personal option, and also what you really want to convey. The same data you can either present as a table or as a chart or a graph, but of course, you should not repeat the same thing, the redundancy is bad. But choices of appropriate table or the graph depends upon the level of the measurement. So, it depends on what level of the measurement you have to choose appropriate tables or appropriate graph, as you can see from this table. It has to be noted that some information conveyed through the table should not be presented again in the graph or vice versa. If the information is same, you should not present in the table plus the graph, simply filling up the pages, or is simple redundancy, that kind of redundancy should be avoided by all means. So, in summary, data summarization is the first step in statistics. It is aimed at extracting useful information and general trends from the raw data. Two methods for the data summarizations are through tables and through the graphs. Although selection of tables or graph is mostly a matter of personal choice, selection of appropriate table or graph depends on the level of measurement. For example, Gregor Mendel's data of dihybrid crows falls under nominal scale, and to summarize it, a contingency table or the bar graph can be used, but not the scatter plot or a histogram, because that falls under the nominal scale of measurements. Hope you have enjoyed it. Thank you.